These are graduated cylinders, and no, they didn't graduate from high school. The graduations are the lines that are on each one. The lines tell you how much is in the container, and these measure in milliliters. The more lines that you have, the more exact the measurement. So the more lines, the better the equipment is to measure out something that you need for a lab. It would be better to measure out 35 milliliters with a graduated cylinder than it would be with a beaker, because there are more lines on the graduated cylinder. Okay, next are funnels. Funnels can come in long stem. Funnels can come in short stem. Long stem, short stem. Funnels. We use funnels to funnel liquids from a larger container into a smaller container, and oftentimes we will use filter paper. The filter paper we'll fold up and put inside the funnel, and then pour the liquid through the funnel and have a clear liquid. Okay, everybody knows what a test tube is. Test tube are those iconic things that you would see in a chemistry lab, and they come in all sorts of different shapes and sizes. They have an open end, they have a closed end, but they all look like test tubes. Now, what do you think this thing is that we are holding the test tubes in? That's right, it's a test tube holder. It holds the medium-sized test tubes, it holds the little-sized test tubes, and even though it may not hold those, we can still stand them up and let them dry. That is a test tube rack, okay? So we have the test tube rack, we have the test tubes, now we have a test tube clamp. Test tube clamp will clamp around there. We actually are not squeezing to clamp it on there, it's spring-loaded. So when you squeeze it, you release it. Squeeze, release, and you have it. And so that way your hands are free to move around, and you can hold this in the Bunsen burner fire or do whatever you need to.
All right, be very, very quiet. We're hunting the most dangerous animal in the entire chemistry lab. It's the dun-dun-dun Bunsen burner. I'm ready for lab. I have my safety goggles and I have my lab coat on. It's time to use the Bunsen burner. This is a little guy that you're going to get very familiar with. Along with the Bunsen burner, we're going to use some other equipment. First of all, it's the ring stand. It's simply a stand with, ta-da, a ring. The ring stand will be used over the Bunsen burner. You can use wire gauze. Wire gauze has a heat-resistant material here in the center. When we put it on the ring, now we can set flat-bottom things like beakers and Erlenmeyer flasks on the wire gauze. What if what you're going to use on the ring stand doesn't have a flat bottom? Okay, I can stop now. Use the pipe stem triangle. We'll put the pipe stem triangle up there, and then we can take something with a rounded bottom, something like a crucible, and it will sit inside the pipe stem triangle just like that. Now, when it's time to get the crucible off of the heat, we can't just reach up there and go, "Ow!" No, we'll use crucible tongs. Crucible tongs, a crucible, and a crucible lid.
These are evaporating dishes. What do you do with an evaporating dish? Well, you evaporate. What we'll do is we'll put a solution in here that has something dissolved in it. We'll put it up over the Bunsen burner, and then when we heat it up, the liquid evaporates, and what we're left with is the substance we want. So these are evaporating dishes. These things are used to crush up large crystals into smaller powder form. They're called mortar and pestle. Here's the mortar, here's the pestle. I've got two different sizes to show you. These you would usually see being used in a drugstore that mixes its own medications and pharmaceuticals. A mortar and pestle. This is a microplate, sometimes called a spot plate. If you don't have a whole lot of the liquid to react in the chemical reaction, you don't want to use a test tube, you can use a spot plate. A spot plate has things called wells. These are little depressions where you could put some liquid and just drop it in. And you would probably use something like this, a little disposable pipette. It has a little squeeze bulb so that you can draw the liquid up, and then you'd put a few drops in that one, and then you would get another pipette with a different chemical and put it in there in the same well and see if there's a reaction. So we have pipettes, and we also have a spot plate. Okay, you probably recognize these. They're beakers. They're not jars, they're not bottles, they're not flasks, they're beakers. Beakers can come in lots of different sizes, and we measure the volume of the liquid inside in milliliters. So when Mr. Womack says go get a 400 ml beaker, he means this beaker right here that holds up to 400 milliliters, 400 ml beaker. We have them in 1,000 ml, 600, 400, 250, 150, 150 ml beakers. These are called Erlenmeyer flasks. They're a little different from the beakers in that they do have a triangular shape. They still will measure general amounts of liquid. We still wouldn't want to use them for an exact amount, but you could measure an approximate amount with these graduations.
Okay, you know Mr. Womack doesn't smoke, not unless his hair is on fire. So, in order for us to light the Bunsen burners, I'm not going to pull out my handy dandy Zippo. So what do I use? A striker. I'll use the striker over the Bunsen burner and light the Bunsen burner.
Okay, here we have volumetric flasks. These are used to make solutions. We don't use them to measure in. We don't use them to heat things in. All we do are use them to make solutions. They only have one gradation, one line on them, and like for example this one says a 250 milliliter volumetric flask. Well, we would use this one to make exactly 250 milliliters of a solution by measuring out the right amount of a solid in there and then dissolve it in water and add the water up to that line, and it would make exactly the concentration of solution that you want. Again, these are volumetric flasks. This is a Florence flask. It looks like a volumetric flask, but it has one very important difference. This one can't stand up on its own because it has a completely round bottom. Look at there. If I tried to stand it up, no, wouldn't do it. This is also called a boiling flask. You would have to clamp this into some sort of equipment to hold it upright over a heat source. You can't heat a volumetric flask, but you can heat one of these. So this is a Florence flask, also called boiling flask. Okay, let's look at some of the smaller equipment that's on your list. What you see in front of you are called stoppers. There are two kinds of stoppers. There are rubber stoppers and there are cork stoppers. A watch glass. A watch glass is simply a piece of glass that has a kind of a curved back. I think you can see that. And we use that for a number of different things. First of all, we'll lay things in there, but we also will put this on top of an evaporating dish, and the things that are evaporating will collect on the underside of the watch glass. So that is a watch glass. So we use this probably the most out of all the glassware. What is it? It's a glass stirring rod. We use it to stir. We can't use metal in a lot of the things we stir because the metal will react. So we use glass, which doesn't react. These are called forceps. In the chemistry lab, we use these, aka tweezers. I'll go along with the fact they look like tweezers, they sound like tweezers, they operate like tweezers, but they are forceps. This, ladies and gentlemen, is a hot plate. No, we don't use it to cook grilled cheese. We use it to heat chemicals. It simply has a little dial. You turn it on, light comes on, and you heat the chemicals. And what should you remember when the light is on? Don't touch the surface. Ow! What we have here, folks, is a triple beam balance. And we call it a triple beam because there are 1, 2, 3 beams. And we'll take the mass of different chemicals with a triple beam balance. More often than not, however, we'll be using, ta-da, the quad beam balance. Why do we call it a quad beam balance? Because we have boom, 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 4 beams, quad beam balance. This one is a little bit more exact than the triple beam balance, and so we'll be using this quite a lot in the chemistry lab. When we're not using the triple beam or the quad beam balance, what we'll be using is the handy dandy electric scale, which also measures to the nearest hundredth of a gram. The two instruments you see here are a scupula, has a curved shape, and a micro spatula. The micro spatula is used for measuring out small amounts of material. The three things that you see here are a striker, a dropper, and a ceramic square. Three long tubes with the valves at the end are called burettes. They measure up to 50 milliliters of liquid. The clamp that they sit in is called a double burette clamp. This is a gas collection tube. It's similar to a burette, but it does not have the valve on it. The apparatus you see here is called a pneumatic trough. The pneumatic trough gets filled with water. There is a gas collection bottle or a wide mouth bottle, a glass plate that is used with the bottle, and there's usually also a hose and some bent glass tubing. These are things that you might use for a gas-producing lab experiment. Ring stands don't always just hold rings. Sometimes they hold test tube clamps. These will hold a test tube over something hot so it can be heated without you burning your hand.